In this problem, we are asked to find the domain of a square root function using algebra and graphing. I've already got the algebra completed for you, so let me just kind of walk you through what happened here. So remember, when you're talking about domain, we're looking for input values. And you assume, or you start with all real numbers. Now when you're dealing with square roots, we have to make sure that our square root stays equal to 0 or greater than, because if it's negative, you know that that's going to be a complex number or the number I, which is not a real number. So we're focusing on real numbers here. So it must be greater than or equal to 0. So that's what you see in the next step. 2x cubed minus 8x greater than or equal to 0. You've got to find those values. So the next few steps, you just see me factoring. I factored out a greatest common factor. I was left with a difference of squares. I pulled that apart, and then what I was left with was 0, 2, and negative 2. And you can think of these as kind of boundary points on your number line. So over to the left, I have just a sketch of a number line, and I put those key numbers in there, negative 2, 0, and 2. And what that does is it divides my number line into 4 parts. So I have the part to the left of negative 2, I have the part between negative 2 and 0, the part between 0 and 2, and the part to the right of 2. So what I have to do is find a value in each of those intervals, test it to see if it works, and if it works, then I include it in my solution set. If it doesn't work, then I'm not going to include it. So you see that out of the 4, I did the testing, and I found 2 sections or 2 intervals that made my function true. And you can see my test points here, and you can use whatever numbers you want within that interval. So I found the interval between negative 2 and 0. When I tested it, it made a true statement. So I have in brackets negative 2 comma 0. Remember, because I can be equal to 0, I can actually use brackets and not parentheses. And then my other interval that I'm going to use in that one with begins at 2, and again, I can include that. And if you're not sure, go ahead and plug in 2, and you'll see that it does work. And then I'm going to go all the way to infinity with that, because that is that interval, anything to the right of 2. And recall with infinity, I have to use that parenthesis. So algebraically, here is my answer or my solution. So now the other part says graph the function and determine intervals on the x-axis for which the radicand is non-negative, or think of that as positive. So I'm going to flip over to my online graphing calculator that I like best most. I'm going to type in my function, 2x cubed minus 8x. And here's my graph. So you can see where it's positive, meaning above the x-axis here. So in my interval, they want to know what intervals that's positive. So you can see right here, I'm positive. So between negative 2 and 0, I'm positive. Between 0 and 2, nothing. And then starting again at positive 2, it appears to just go to infinity. So my intervals between negative 2, 0, and 2 and beyond. So if I flip back to my algebra, that's exactly the same thing algebraically between negative 2 and 0 and positive 2 and beyond. So the answer using algebra and the answer graphically yielded me the same